What if the universe itself had an expiration date, and the scientists who discovered it decided it was better if you never found out? Think about that for a second. We send rovers to Mars. We photograph black holes 55 million light years away. We put a car in orbit just because we could. And yet, some of the most disturbing ideas in modern cosmology barely make it past the walls of academic journals. Not because they're wrong, but because some truths are so staggering, so reality-bending, that even brilliant minds go quiet when they come up. Welcome to Space Secrets, where we don't look away from the hard stuff. I'm so glad you're here today, because this one is going to shake something loose in how you see the night sky. We're counting down the 10 most terrifying space theories that scientists rarely talk about in public. And trust me, by the time we hit number 1, you're going to want to sit with it for a while. Stay with me all the way to the end, because these ideas only land with their full weight when you see them build on each other. And if this is the kind of curiosity-fueled deep dive that gets your brain fired up, hit subscribe right now, because on Astromat, this is just the beginning. Let's start with something that sounds almost too simple to be terrifying. Everything runs down. Your morning coffee gets cold. Your car runs out of gas. Even the mountains, given enough time, erode into flat plains. This isn't just a life observation. It's one of the most ironclad laws in all of physics. The second law of thermodynamics tells us that in any closed system, disorder always increases. Energy spreads out. Things fall apart. And here's the gut punch. The universe is a closed system. Scientists at institutions from Caltech to Princeton have spent decades running the numbers, and what they keep finding is deeply unsettling. Given enough time, we're talking timescales so enormous they make the current age of the universe look like a blink. Every star burns out. Every black hole evaporates. Every last pocket of usable energy spreads so thin across space that nothing can ever happen again. Not a spark. Not a signal, not a thought. Physicists call this heat death, and NASA's own data from the WMAP and Planck missions, which mapped the cosmic microwave background radiation across the entire observable universe, actually supports the conditions that make this outcome not just possible, but likely. Now, if that isn't enough, there's a second theory standing right beside it with a different kind of ending. The Big Rip. Here's the thought experiment. Imagine you're stretching a rubber band. Slow at first, then faster, then so fast the rubber band doesn't just snap, it disintegrates. That's what dark energy may be doing to the universe right now. NASA's supernova observations first confirmed that the universe's expansion isn't slowing down. It's accelerating. And some models suggest that acceleration could increase without limit, eventually ripping apart galaxies, then solar systems, then planets, then atoms themselves. Two theories, two endings, both grounded in real physics, both pointing toward the same conclusion, that the universe, for all its staggering beauty, may have always been moving toward silence. And that silence? It might already have a few residents, because the next theory suggests that somewhere in the cold mathematics of probability, minds are flickering into existence out of pure chaos, with no memory, no past, and no future. Here's a question that sounds like it belongs in a philosophy class, but is actually being debated in the most serious physics departments in America right now. How do you know you're real? Not in a dramatic way, in a mathematical way. Let's start with Ludwig Boltzmann, a 19th century physicist whose ideas were so far ahead of their time they nearly broke him. He proved that given a large enough system and enough time, random fluctuations in energy can spontaneously assemble into ordered structures. Small ones at first, but theoretically, and this is where it gets uncomfortable, given infinite time and infinite space, those fluctuations could assemble something far more complex, like a brain, a fully formed conscious mind, complete with memories of a life that never happened, sensations of a world that doesn't exist, and the experience of reading a YouTube comment, appearing out of nothing but the random churning of particles. Physicists call this a Boltzmann brain. And the reason serious cosmologists at institutions like Stanford and MIT lose sleep over it is this. In an infinite or near-infinite universe, the number of these randomly assembled conscious observers could vastly outnumber beings like us, who evolved naturally over billions of years. Which means statistically, and this is the part that nobody likes to say out loud, It is arguably more probable that you are a Boltzmann brain flickering into existence for just this moment than that you are the product of 4 billion years of Earth's evolution. Now pair that with the false vacuum theory. The universe, according to quantum field theory, may not be sitting at its lowest possible energy state. Think of it like a ball resting in a small dip on a hillside. Stable enough for now, but not truly at the bottom. If the universe is in what physicists call a false vacuum, then somewhere out there, right now, a bubble of lower energy could be expanding outward at the speed of light. No warning, no detection, just a rewrite of every physical law in its path, erasing everything it touches. The Hubble Space Telescope and subsequent NASA Deep Field observations have shown us just how vast and ancient this universe is. And the older and larger it is, the more room there is for both of these nightmares to be quietly, mathematically true. You can't disprove you're a Boltzmann brain. You can't outrun a vacuum collapse. And somehow, the universe doesn't seem to care either way. But if random chaos can build a mind and reality itself might be fragile, then why, across all of this vast and ancient cosmos, has not a single other civilization ever said hello? Imagine you send out a signal, a radio broadcast clear and deliberate, into a neighborhood you believe is populated. You wait an hour, a day, a decade. Nothing comes back, no response, no acknowledgement, not even interference. Just perfect, unbroken silence. Now imagine that neighborhood is the entire observable universe. 400 billion stars in our galaxy alone. 2 trillion galaxies within reach of our best telescopes. And NASA's Kepler Space Telescope confirmed what scientists had long suspected. Planets are not rare. They are everywhere. Rocky ones. Ones sitting in the habitable zone of their stars. Ones with the right chemistry, the right distance, the right conditions for liquid water and complex molecules. The math is almost offensively generous toward life existing out there. And yet, since 1977, when the legendary Big Ear radio telescope in Ohio captured the famous WOW signal, a burst of radio frequency so perfectly structured it stunned researchers and was never explained and never repeated, we have heard nothing. Decades of SETI research, some of it funded through American universities and NASA-affiliated programs, scanning billions of frequencies across the sky, and the universe has not whispered back a single confirmed word. Enrico Fermi, lunching with colleagues at Los Alamos back in 1950, put it simply: if intelligent life is statistically almost certain to exist, where is everybody? That question became the Fermi paradox, and in 70-plus years of space science and discovery, nobody has answered it. But some physicists have proposed an answer so dark, it reframes everything. The dark forest theory. It suggests that the universe is not silent because life is rare. It is silent because every intelligent civilization that has survived long enough understands one brutal truth. To broadcast your existence is to invite your destruction. In a cosmos of finite resources and unknowable intentions, silence is not emptiness. Silence is strategy. Every civilization is a hunter moving through a dark forest, knowing others are out there, trusting no one, revealing nothing. If that theory is correct, then every signal we have ever sent into space, every broadcast, every golden record on Voyager, every radar pulse, may have been the single most dangerous thing humanity has ever done. And if the universe can hide entire civilizations from us, it makes you wonder, what else are we completely failing to see, even when we think we're looking directly at it? Here is something that legitimate, credentialed physicists at some of America's most respected research institutions will tell you with a straight face. Everything you have ever seen, touched, tasted, or loved may not be fundamentally real. Not in a poetic sense. In a mathematical, physics-based, peer-reviewed sense. Let's start with the simulation hypothesis. The core logic is almost annoyingly simple. Right now, in 2024, humans can already build digital environments populated by entities that respond to stimuli, make decisions, and interact with their world without knowing they exist inside a computer. We are maybe decades away from simulations indistinguishable from base reality. Now think forward 1,000 years. a million. If any civilization ever reaches the computational power to run what theorists call ancestor simulations, detailed recreations of conscious experience, then the number of simulated realities would quickly and vastly outnumber the one original reality. Which means, by pure probability, the odds that you are in the one true base reality are almost vanishingly small. Elon Musk has said publicly the chances we are not in a simulation are 1 in billions. Researchers at places like MIT and the University of Washington have explored whether the laws of physics themselves carry signatures of computational constraints, like a universe running on code that has limits, just like any software does. Now layer on top of that the holographic universe principle, which comes not from science fiction, but from string theory and black hole physics, research that grew significantly out of theoretical work connected to institutions like the Kavli Institute and Caltech. The principle suggests that everything happening in our three-dimensional reality may actually be encoded on a two-dimensional surface at the boundary of the universe. Like a cosmic IMAX projection, depth, texture, time, and mass, all rendered from flat information we can barely begin to read. NASA's own deep space observations have shown us that the universe behaves in ways that consistently surprise even our best models. Dark matter we cannot see, dark energy we cannot explain, constants that seem almost surgically tuned to allow existence at all. The map keeps failing to match the territory. And the most unsettling possibility in modern space science is not that we are missing data. It is that the territory itself may be something our minds were never designed to directly perceive. And if we can't fully trust the nature of reality around us, then prepare yourself. Because the final theory we're about to explore suggests that your consciousness may not just be observing this universe, but may actually be one of the forces that decides how it behaves. Here's the one that tends to stop people completely. Not because it is the most violent theory, not because it describes the largest explosion or the coldest ending, but because it is the most personal. Because if it is true about you specifically right now, in a way that no space science fact has ever been true about you before. Let's begin with something real and tested and accepted in physics departments across America. Quantum mechanics, the science that gave us transistors, MRI machines, and the entire digital world, tells us that particles do not have definite states until they are observed or measured. Before observation, a particle exists in superposition, meaning it holds multiple possible outcomes simultaneously. The act of measurement forces it to resolve into one. This is not philosophy. This is the foundation of modern physics, confirmed in laboratories from Caltech to MIT to Fermilab in Illinois. Now, Hugh Everett, a Princeton physicist working in the 1950s, looked at this and asked a question that the establishment was not ready for. What if the wave function never actually collapses? What if instead of one outcome being chosen, every possible outcome occurs, each one branching into its own equally real universe? This became the many worlds interpretation, and today it is not a fringe idea. It is one of the most seriously debated frameworks in theoretical physics, with leading American physicists openly supporting it. Here is where quantum immortality enters, and where it gets deeply unsettling. If every quantum event branches into all possible outcomes, then in every situation where you could survive or not survive, there exists a branch where you do survive. No matter how unlikely, your conscious experience, by definition, can only ever continue in branches where you remain conscious, which means from your own first-person perspective, you may be mathematically incapable of experiencing death. You simply keep finding yourself in the branches where you made it. Think about that against the backdrop of everything NASA has shown us about the scale of this universe. Billions of years, billions of galaxies. If the many worlds interpretation is correct, that entire cosmic history has been branching and rebranching into an incomprehensible number of parallel realities since the very first quantum event after the Big Bang. You are not one person in one universe moving toward one ending. You may be a living thread woven through an infinite multiverse, persisting in ways your conscious mind will never fully be able to trace or understand. And that might be the most terrifying space fact of all. Not that the universe is vast and cold and indifferent, but that you may be far more deeply entangled with its infinite structure than any telescope, any rover, any space discovery has yet had the power to reveal. So let's take a breath and sit with what we've actually covered today. We started with the physics of endings, heat death and the Big Rip, and learned that the universe is not eternal in any comfortable sense. The same thermodynamic laws that cool your coffee on a Tuesday morning in Ohio are, on a cosmic scale, winding down everything that has ever existed. We discovered that randomness, given infinite time, can produce conscious minds from nothing, and that reality itself may be sitting on an unstable ledge, one quantum event away from being rewritten at the speed of light. And we ended where it gets the most personal, with the possibility that your consciousness is not a passenger in this universe, but something woven so deeply into its quantum structure that the multiverse itself may be branching around your continued existence right now. Here is what makes all of this more than just fascinating space science. NASA's upcoming missions, from the Nancy Grace Roman Space Telescope to continued deep field observations pushing the boundaries of the observable universe, are not just looking for pretty pictures. They are actively gathering the data that will test these theories. American scientists right now are building the instruments that could one day tell us whether the vacuum is stable, whether the expansion is accelerating toward a big rip, whether the cosmos carries the fingerprints of computation. We are living in the most extraordinary moment in the history of human curiosity. And here is the final thought I want to leave you with. Every universe mystery we explored today, every terrifying, reality-bending, mind-expanding idea was discovered not by looking away from the darkness, but by having the courage to ask the uncomfortable question out loud. The universe is under no obligation to be easy to understand, but it keeps revealing itself to the ones who refuse to stop asking. You are one of those people, and that matters more than you know. If today's science explained something in you that needed explaining, subscribe to Astromat right now. Every single week, we take the deepest, strangest, most awe-inspiring corners of space exploration and physics and bring them home in a way that actually makes sense. New videos drop every week, and trust me, we are just getting started. The cosmos is enormous. Your curiosity is bigger. Let's keep going. And that's a wrap on today's journey. Honestly, the fact that you stuck around through all of it, through vacuum collapse and Boltzmann brains and the very real possibility that your consciousness is threading itself through an infinite multiverse, that says something about you. You are exactly the kind of curious, clear-eyed thinker that this kind of science needs more of. And as NASA keeps pushing deeper into the cosmos with every new mission and every new discovery, understanding these ideas isn't just fascinating. It's how America stays at the forefront of asking the questions that actually matter. I genuinely love exploring this stuff with you every week. There is nothing quite like that feeling of having the universe crack open just a little bit wider than it was before. I'll see you in the next one.